Hello everyone, today I'm going to talk with you about resonance. What resonance is, it is the different ways in which electrons can be present in a certain molecule. The most famous molecule with a resonance structure probably is benzene, which looks like this. What can happen is that the electrons in this double bond will go to here, these two here, this to here. And what then will happen is that you get the benzene will look like this. And that's why benzene is often written like this, because so with a circle, because those double bonds can circle throughout the molecule. Because if you look at this, these double bonds can make the same motion, so it can go to the right, and then you get this molecule again. Then this happens, and you get this, and then like this. So the double bonds will move throughout the molecule. So that's why they often is just a circle. When you draw resonance structures, you have to use this arrow, and you need to be careful that you don't use this one, because this is the equilibrium arrow. And if you use this one, you say that a reaction takes place, but because the molecule stays the same during resonance structures, this isn't the case. So you can't use this one, you have to use this one. Another nice example for resonance structures are this. This is ozone with a negative charge on this oxygen, positive here, and then double bond, and then no charge on this oxygen. But what can happen is that one of those three free electrons on this oxygen can go through here, and then one of the two bonds between these oxygens will go to this oxygen, and then you will get this molecule. So now the negative charge is on the left oxygen instead of the right, and because you can move this charge between the two oxygens, ozone is stable even though the molecule itself has two charges in it. So you can use resonance to determine the stability and therefore also the reactivity of a molecule, because the more stable a molecule is, the less reactive it is. A good way to do it is if you first look at phenyl. Phenyl is an benzene with attached an alcohol group. So benzene and OH. And now you can, if this H here is removed, you get phenylate, which looks like this. But what now can happen is that one of those three electrons here moves over here, and then this bond here will move towards this carbon, and then you get the first resonance structure of phenylate, which looks like this. Yeah. With a negative charge here. So you see that the charge moved from this oxygen towards this carbon. What now can happen is that these electrons go here, and these go here. Then you get the next resonance structure, which is this. The negative charge here. And then finally what also can happen is that this goes here, and these go here. And then you get the negative charge here. So you see that from the phenylate, the charge can be put on 1, 2, 3, 4 different atoms within the molecule, which makes this molecule relatively stable. If you, for instance, look at ethanol, which is this, and the same would happen to ethanol, so the H plus would be removed. You will get this. But because oxygen is more electronegative than the carbons over here, these electrons can't move at all in any direction, so the charge is only put on the oxygen atom here. So this molecule is way less stable than this molecule, which makes also that this molecule is way more reactive, because the less stable a molecule is, the more reactive it is. A nice tip for drawing resonance structures is to always use the Lewis structures. If you, for instance, look at an acid like this, and just like before, we remove the H plus on the alcohol, which will leave this with this ion, the minus charge here. If you look at it like this, it might be difficult for you to determine where the electrons would move. But if you now first draw the Lewis structure of the whole molecule, or at least in this case of the oxygens, then you see, okay, I have three electron pairs on this oxygen available, two over here, and I have this double bond which can move. And then it might be easier to determine, okay, what can happen is one of these electrons goes here, and one of these electrons goes here, and then you can draw the resonance structures probably easier because you see where the electrons are in the molecule. So then it's easier for you to say, okay, you probably will get this as a resonance structure. And this again looks a lot like ozone, where the negative charge is put over the two different oxygens. So this was ozone. So you see that this is a very similar way in using your electrons to distribute the charge than it was at ozone.